Paper Radio, generated commentary on the latest artificial intelligence papers.
Next, we'll be talking about the paper DiffSHEG, a diffusion-based approach for real-time speech-driven holistic 3D expression and gesture generation.
The paper was written by Jiaming Chen, Yunfei Liu, Jianan Wang, Ailing Zheng, Yuli et al. From International Digital Economy Academy and Hong Kong University of Science and Technology.
Stay tuned as we take you through the paper and discuss its implications. So, on page 1, the authors introduce DiffSHEG, which is a diffusion-based approach for speech-driven holistic 3D expression and gesture generation. It aims to create synchronized expressions and gestures based on spoken words. Currently, previous works only focus on generating either expressions or gestures individually. So this paper is trying to fill that gap.
Right, so we see here that they created a unified system for co-speech expression and gesture generation based on diffusion model. This allows for the omnidirectional information flow from expression to gesture, which helps in better matching the joint expression-gesture distribution.
I find it interesting that they mentioned the use of outpainting-based sampling strategy for arbitrary long sequences. This could potentially offer flexibility and computational efficiency, which hasn't been addressed before.
Yes, that's true. Also, the fact that they're proposing a method that generates high-quality synchronized expressions and gestures driven by speech is a big step forward in the field of digital humans and embodied agents.
The authors discuss that while existing research focuses on individual expression or gesture generation, there's a need for a method that targets both at the same time. Their proposed approach seems promising in filling this gap. The diffusion procedure mentioned is quite innovative, as is the expression generator and gesture generator. They also tested their method on public datasets, achieving state-of-the-art performance.
That's a lot of ground covered. Let's move on to page 2 now. All right, let's dive into the details of the paper. The researchers propose a new method called DiffSHEG for speech-driven holistic expression and gesture generation. This method uses diffusion models with a unified expression gesture denoising network. This approach is unique because it captures the joint distribution of expression and gesture, something that hasn't been done before.
Yes, Tom, the paper is really interesting. The authors also introduce a fast outpainting-based partial autoregressive sampling, a pause method. This allows for efficient generation of arbitrary long sequences without depending on previous frames during training. This provides more flexibility and efficiency in the process.
I think one of the key contributions of this paper is that it's the first attempt to explicitly model the joint distribution of expression and gesture. That means it tries to understand how speech influences both facial expressions and body gestures simultaneously.
That's correct, Lou. The researchers also designed a unidirectional expression gesture, UNIEG, transformer generator, which enforces a flow from expression to gesture. This helps maintain the natural temporal alignment between speech and motion.
Yeah, I agree with both of you. The method also achieves state-of-the-art performance on 2 new public datasets, demonstrating its effectiveness in both quantitative and qualitative evaluations. User studies reveal that the method excels in terms of motion, realism, synchronism, and diversity.
That's great news, Laylam. So, the researchers have made some significant progress in the area of speech-driven expression and gesture generation. Let's see what the next page brings. All right, let's break down the content on this page. This paper introduces a new approach called DiffSHEG for generating realistic co-speech expressions and gestures in real time. The model uses a diffusion-based approach and aims to create synchronized and diverse gestures and expressions that adapt to different types of audio input.
This model works by breaking down the audio and motion sequences into smaller clips. It encodes the audio into low-level features and high-level Hubert features, which are then concatenated with any additional optional conditions like text. This combined information is then fed into a UNIEG transformer denoiser to remove noise and create a fused feature that captures the relationship between speech, expression, and gesture.
The paper proposes a unified framework with unidirectional information flow from expression to gesture, which helps better capture the joint distribution of speech, expression, and gesture. They use a fast-out painting-based partial autoregressive sampling, FOPA, a strategy to generate motion sequences in real time. This method creates partially overlapping clips with smooth motion transitions.
One interesting aspect of this paper is their proposal for a faster outpainting, partially autoregressive sampling, FOPA strategy. This method allows for the generation of partially overlapping clips with seamless motion transitions, enabling real-time streaming inference.
The paper also highlights the importance of maintaining a unidirectional information flow from expression to gesture. This is because expressions can serve as cues for gestures, while gestures have a minimal effect on expressions, particularly the lips. Overall, the DiffSHEG framework shows promise in generating realistic and diverse co-speech expressions and gestures in real time using a diffusion-based approach.
All right, so on this page, the researchers explain the model architecture of their proposed approach called DiffSHEG. It's a framework that uses audio encoding, male spectrogram, and Hubert features to extract speech information. They also mentioned the motion speech fusion residual block, which helps in conditioning motion on speech and aligning them in the temporal domain. Furthermore, they describe the style-aware transformer block, which injects global conditions such as style and diffusion step into the model.
This model seems really promising because it allows for real-time smooth motion generation by adapting the repaint algorithm to dim sampling. They also introduced a unidirectional expression to gesture information flow, which helps in capturing the joint distribution of expressions and gestures. This increases the realism and coherence of both motions.
What I find fascinating here is the idea of directly concatenating the motion features with the speech embeddings, resulting in a natural temporal alignment between audio and motion. This could potentially lead to better synchronization of audio and visual elements in AI-generated content.
Another intriguing aspect of this paper is the use of multitask learning, which shares low-level features between tasks and benefits each other. This could greatly enhance the performance of AI models trained on multiple tasks simultaneously.
In addition to the above points, the authors also introduced three loss functions: the noise prediction loss, velocity loss, and Huber motion reconstruction loss. These losses help to optimize the model's performance and ensure accurate motion predictions based on speech inputs. Overall, this paper presents a detailed framework for generating realistic and synchronized speech-driven 3D expressions and gestures, opening up opportunities for advancements in AI-generated content and human-computer interaction.
All right, so on this page, the researchers are describing their method for creating realistic facial expressions and gestures in real time using artificial intelligence. They've developed a technique called DiffSHEG that uses a diffusion-based approach. They mention using the beat dataset and the show dataset for training their model. They've compared their model to other methods like CAM, diff gesture, diffuse style gesture, and on the beat dataset. On the show dataset, they've compared their model to talk show and list 3. They've trained their model on 5 3090 GPUs and mentioned some key technical details like the use of outpainting dim sampling and blending at the last two sampling steps for better consistency. What do you think about this, Jane?
Yes, Tom, that's quite fascinating. So the researchers have created this model that can generate realistic facial expressions and gestures in real time using AI. They've tested it against several other models on 2 different datasets, beat and show, and they've achieved impressive results. It's really exciting to see the advancements in AI that allow for such realistic and dynamic creations.
Yeah, I agree with both of you. The fact that they used a diffusion-based approach shows the versatility of this method in generating complex and detailed motions. Plus, the use of outpainting and dim sampling techniques make it much faster and efficient compared to previous methods. And it's not just about the expressions and gestures, but also the consistency and seamless transitions between them. That's something we should definitely look into further.
I absolutely concur with Lou. The ability to create realistic and dynamic motions in real time opens up a whole new realm of possibilities in various fields like robotics, virtual characters, and digital entertainment. This could potentially revolutionize the way we interact with eye-powered avatars, making them more lifelike and engaging.
Indeed, the advancements in eye technology, such as diffusion-based approaches and outpainting techniques, are incredibly promising. These methods hold great potential in improving the realism and fluidity of animated characters in various applications, thus enhancing user experiences and engagement. It will be exciting to see how these techniques continue to evolve and be integrated into real-world systems.
So basically, this paper presents a novel approach called DiffSHEG that uses diffusion models to generate realistic facial expressions, lip sync, and gestures for real-time speech-driven 3D avatars. The model outperforms existing baselines on both the beat and show datasets in terms of realism, agility, and diversity of expressions and gestures. It also demonstrates better speech motion, alignment, and naturalistic blink frequencies.
This paper focuses on creating more lifelike avatars that can mimic human-like actions and emotions. It does this by developing a new technique that uses machine learning to create realistic movements based on spoken words. The researchers tested their model against others and found it produced more natural-looking gestures and expressions. One of the most intriguing aspects of this paper is the use of diffusion models, which are becoming increasingly popular in the field of eye. These models allow for impressive feats such as generating images or text based on just a few prompts. In this case, they're used to create highly realistic animations of humans speaking, making the eye-generated characters appear almost indistinguishable from real people.
Another fascinating aspect of this research is the potential for these eye-generated avatars to be used in various industries, including entertainment, gaming, and even communication. Imagine having a virtual friend that can respond to your words with realistic gestures and expressions. That's what this technology could enable in the near future.
Although the paper's findings are quite promising, there are still some challenges to overcome. The authors mention that some baseline methods like VKV can struggle with capturing high-frequency gestures or showing enough diversity in their animation. Additionally, the researchers acknowledge that their method is still not perfect, as some jittering issues remain. Nonetheless, this paper presents a significant step forward in the development of more lifelike eye-generated characters.
All right, so let's start by talking about the main points of this paper. The researchers have developed a new technique called DiffSHEG, which stands for Diffusion-Based Approach for Real-Time Speech-Driven Holistic 3D Expression and Gesture Generation. This paper aims to generate more expressive and diverse gestures and head poses based on spoken language.
Right, so they've created a model that uses diffusion-based techniques to generate realistic and diverse gestures and head poses in response to speech. This is done by training a large language model to understand the meaning behind words and phrases, and then using that information to control the gestures and head poses. This is really exciting because it shows how I can learn complex tasks like understanding human emotions and expressions just by listening to speech. It could potentially lead to more realistic avatars or digital characters in video games and virtual reality experiences.
Yeah, and imagine if we could use this technology to create lifelike digital actors in movies or even control robots in real life with just our voice. That would be pretty amazing.
Absolutely. I agree. But let's talk about the performance of this model. According to the paper, DiffSHEG outperforms other models like TalkShow and LS3 in terms of gesture and head pose diversity, as well as agility. They've also compared it with different baselines like Cam, Diff Gesture, DeSki, and LDA, and found that it performs better.
Yes, and they even did user studies to see if people prefer the expressions and gestures produced by DiffSHEG. Turns out people liked it a lot more than the other methods, finding it more realistic, synchronized, and diverse.
In summary, this paper presents a novel eye-driven technique that can generate lifelike expressions and gestures based on spoken language. By leveraging diffusion models and large language models, it shows promise in improving the realism and diversity of digital characters in various applications.
Okay, so let's begin by looking at this paper, which aims to create a method for generating realistic and diverse 3D facial expressions and gestures based on spoken language. The team behind this paper, Jiaming Chen, Yunfei Liu, Jianan Wang, Ailing Zhang, Yu Liu, have developed a diffusion-based approach called DiffSHEG for achieving this goal.
This method uses a deep learning model that iteratively refines the generated facial expressions and gestures, making them look more realistic and dynamic over time. It's like gradually painting a picture to make it look more lifelike.
One of the key aspects of this paper is the extensive user study conducted on 2 different datasets, Beat and Show. They compared their model with several other state-of-the-art baselines to demonstrate its superior performance in terms of various metrics such as realism, gesture, speech synchronism, expression, speech synchronism, and motion diversity.
Yes. And what's impressive is that they also proposed new evaluation metrics specifically for holistic motion, including fresh distances for generated and real data in gesture feature space. They also looked at the percent of correct motion parameters and beat alignment between audio and gesture beats.
In addition, they discussed the limitations of some baselines, such as the ELS 3G method, which generates jittering motion, and CAM, which produces slow motions. They also highlighted that some metrics like diversity and beat alignment may not fully represent human perceived visual quality.
So, to sum up, the researchers have created a powerful technique called DiffSHEG, which can generate realistic and diverse 3D facial expressions and gestures based on spoken language using a diffusion-based approach. Their method significantly outperforms existing techniques in terms of various metrics, and they have proposed new evaluation metrics specifically for this task.
Indeed, this could potentially revolutionize the way we create lifelike animated characters and avatars in virtual reality, gaming, and even social media. Imagine being able to express yourself through your digital representation just by speaking.
All right, so on this page, the researchers are discussing the effectiveness of their method. They compare it against other models like TalkShow and ELS3, demonstrating that their approach performs significantly better. They mention that their model can generate more diverse and realistic expressions and gestures compared to others.
They also discuss the importance of the unidirectional condition flow design in their model UNIAG transformer. This design allows for effective capture of the expression gesture joint distribution, which is a critical factor in generating realistic expressions and gestures.
On top of that, the researchers also introduced a fast outpainting-based partial autoregressive sampling (FAPAS) strategy with DDIM, which enables their model to achieve real-time inference on arbitrary length streaming audio. This makes their method faster and more efficient compared to other models.
Furthermore, they conducted ablation studies to validate their design choices. They tested different architectures, and their model consistently outperformed them in various metrics such as free shape distance, VA, diversity, and semi-order scores.
The paper acknowledges the help provided by Xiaojun Liu and Xioxin Fan in rendering the metahuman character in Unreal Engine. Overall, this paper presents a novel diffusion-based approach for speech-driven holistic 3D expression and gesture generation, showing significant improvements over existing methods.
All right, so this paper focuses on generating realistic, expressive gestures based on spoken language input. It uses a diffusion-based approach which involves adding noise to the input, running it through a neural network, and gradually removing the noise to create a high-quality result. The researchers have tested their model on various datasets, demonstrating its effectiveness in creating lifelike gestures and facial expressions that match the spoken words. This could potentially be used in virtual characters or avatars to make them seem more human-like and engaging during interactions.
That's right, Tom. The model they propose, called DiffSHEG, has been trained on several datasets to generate realistic 3D expressions and gestures driven by speech. These include Ixanul Habi's work on conversational gestures, Kei Hasegawa's study on speech-to-gesture generation, and others like Jonathan Hu's denoising diffusion probabilistic model. All these studies contribute to the overall development of the model.
Yes, Tom and Jane, the model's performance is quite impressive. When applied to various data sets, it has shown great potential in capturing the nuances of human gestures and facial expressions when matched with spoken language.
Indeed, Lou. With this technology, virtual characters could become much more interactive and realistic in the future. Imagine being able to converse with a virtual character that not only understands your words, but can also react with lifelike gestures and facial expressions. It would make the experience feel almost like talking to a real person.
This research indeed holds great promise for enhancing the way humans interact with artificial intelligence systems. By incorporating natural language processing and advanced machine learning techniques, we could develop more intuitive and immersive communication tools that could significantly impact various fields such as entertainment, education, and even mental health therapy.
Thank you all for sharing your insights. Let's move on to the next page now and continue our discussion. So, to conclude our discussion on the paper DiffSHEG, a diffusion-based approach for real-time speech-driven holistic 3D expression and gesture generation, by Jumping Chen et al., we learned that this technology aims to create realistic and expressive 3D characters in real time based on speech input. This advancement could potentially revolutionize the gaming industry and the entertainment sector.
It has great potential to make virtual characters come alive and deliver emotions more convincingly, which could greatly enhance user experiences in video games, movies, or even virtual reality environments.
For example, imagine playing a game where your character responds to your voice commands not only with words, but also with lifelike gestures and facial expressions. That's something we could see becoming a reality in the near future.
Yeah, it's truly exciting to think about the impact this could have on various industries, especially in entertainment and communication.
That's all we have time for today. Thank you so much for listening. Be sure to tune in next week when we'll be diving into another fascinating eye paper. Until then, goodbye and keep exploring the world of eye with us.
Goodbye, see you next time. Remember, if you like what you heard today, share it with your friends and family, and don't forget to join us again next week.